is of our problems on a discrete Fourier transform. We already learned what are all the properties for the Dtft and what are the basic equation. Now we will solve the problems. The first problem here it is given as find the Dtft of the signal, that is x of n is equal to y raised to n u of n, where our mod of alpha is it is less than 1. We have to draw the magnitude spectrum for the given equation. Now we will consider the equation, that is x of e raised to j omega is equal to summation infinity x of n omega n. For x of n, that is alpha raised to n u of n e raised to minus j omega n. Based on the u of n, we can take the limit as, we can consider the limit as n is varying from 0 to infinity. Then alpha raised to n e raised to minus j omega n. Then I can write as just small modification here we are going to do, that is about we're taking a alpha e raised to minus j n, taking n as the whole power. Then the equation I'm going to use as summation when varying from 0 to infinity alpha raised to n, the equation is going to be 1 divided by 1 minus alpha. Based on this formula I can write as the equation is going to be x of e raised to j omega is equal to 1 divided by 1 minus alpha e raised to minus j omega. This is the equation you will be getting. Then the magnitude spectra for alpha, it is very 1 for the values, and from minus 1 to 0 for the negative values. The spectra is going to be like this. For alpha varying from 0 to 1, you will be getting like this signal. The signal where it is varying, it's going on continuing. When at omega is equals to 0, at omega is equal to 0, you will be getting as 1 divided by 1 minus alpha. Then when at omega is equals to pi, you will be getting as x of e raised to j omega as 1 divided by 1 plus alpha. This is what here it is. At 0, you will be getting as 1 divided by 1 minus alpha. At pi or minus pi, you will be getting as 1 divided by 1 plus alpha. This is of the where our alpha is varying from 0 to 1. When alpha is varying from minus 1 to 0, when alpha is at alpha is equal to 0, sorry, omega is equals to 0, x of e raised to j omega is going to be 1 divided by 1 minus alpha. When omega is equals to plus pi, x of e raised to j omega is going to be 1 divided by 1 plus alpha. Observe here, the figure is different. Here at 0, you will be getting as 1 divided by 1 minus alpha in a lower side. Then when at pi or minus pi, you will be getting as 1 divided by 1 plus alpha. You will be getting the signal, the reverse of the previous one. This is about the magnitude spectrum for a given signal, that is alpha raised to n u of n. Next we will go with the next problem, that is find the Dtft of the signal x of n is equal to 13531. Here sample values are given and they are telling that fifth value is at the 0th position. And what you have to do, we have to evaluate x of e raised to j omega at omega is equals to 0. We know that the equation x of e raised to j omega is of summation n varying from minus infinity to plus infinity x of n e raised to minus j omega. Then it is going to be here for the n value. For the n value, it is varying. Here it is of minus 1, here it is of minus 2, and here it is of minus 1, and it is the position. In terms of position, we are going to check in terms of time. N is varying from minus 2 to plus 2, x of n e raised to minus j omega n. Then substitute for n value as minus 2 to plus 2, x of minus 2 e raised to j2 omega plus x of minus 1 e raised to j omega plus x of 0 plus x of 1 e raised to minus j omega n plus x of 2 e raised to minus 2 omega you will be getting. Then we have now what, now you substitute for x of minus 2, minus 1, 0, x of 0, x of 1, x of 2. The considering a samples here. Okay. Then x of minus 2 is of 1 e raised to j 2 omega plus x of minus 1 as 3 e raised to j omega. X of 0 is taken as 5. So you have to substitute there. Plus x of 1 is of 3. 3 into e raised to minus j omega. Plus x of 2 is of 1 e raised to minus j 2 omega. Then if I solve for this and also write the equation in terms of cos and sine. Okay. What you will be getting? You will be getting for this equation, you will be getting as cos 2 omega minus j plus j sin omega. Here cos omega plus j sin omega. Here cos omega minus j sin omega. Here for cos 2 omega minus j sin 2 omega. If you after that you have to modify that equation, then you will be getting as x of e raised to j omega is equal to 5 plus 6 cos omega plus 2 cos 2 omega. You will be getting off. Then the condition at omega is equals to cos of 0 is 1, cos of 0 is 1, 5 plus 6 plus 2, you'll be getting as 13. Okay. And the next problem is of find the DTFT of delta of n and draw its spectrum. Solution: x of e raised to j omega is equal to summation n varying from minus infinity to plus infinity x of n e raised to minus j omega n. X of n is of delta of n. They given that you have to substitute e raised to minus j omega n, but our delta is going to be existing at 0 only. Therefore delta of n is equal to 0 for not n is not equal to 0, and delta of n is equals to 1 when n is equals to 0. Therefore what I can write, x of e raised to j omega is going to be equal to delta of 0 and omega should be 0 only, e raised to 0. So I can write here as that is going to be equals to 1. The spectrum is shown in figure, that is where omega is varying from 0 to any of the values. It will be constant, that is it will be 1 only. This is the next. We will go with the next problem, that is show that the DTFT of x of n is equals to 1 when n is varying from minus infinity to plus infinity is given by x of e raised to j omega, that is equals to summation k varying from minus infinity to plus infinity 2 pi delta of omega plus 2 pi k. Then the solution is going to be, what is the x of e raised to j omega? I can write the equation as it is varying at 0, it will be 2 pi, because here the magnitude is of 2 pi for the delta function, and it will be varying 2 pi, increments of 2 pi means periodically it is varying with the period of 2 pi, right? Based on that I can write the signal like this, that 0 2 pi, at 2 pi again it's 2 pi, and for all the values whatever it's going in the positive way and also in the negative way, it will be 2 pi only. Okay, then we know that x of n is going to be equals to 1 divided by 2 pi integration minus infinity to plus minus pi to plus pi x of e raised to j omega e raised to j omega n d omega. But omega is, it will be 0, yes, for delta function. For that reason what I can write here, 1 divided by 2 pi, the period the magnitude is of 2 pi only, e raised to j 0 n, 2 pi get cancels, you will be getting as 1 only. Therefore x of n is equal to 1. The DTFT is going to be x of e raised to j omega is equals to summation k varying from minus infinity to plus infinity 2 pi delta of omega plus 2 pi k. Okay, then DTFT of is consisting of the all the delta functions, that is impulse response, we already come across this, how it is going to be representing. So I can write the equation as delta of n plus delta of n minus 1 plus delta of n minus 2, it's going on. So I can briefly write the equation as summation varying k is varying from 0 to infinity delta of n minus k. Putting n minus k is equals to m. Therefore, x of n is equals to u of n is equals to summation m is equal to n to minus infinity delta of m. Then u of n is equals to summation m is varying from minus infinity to plus n delta of m, where m is the example variable. So we can change that to u of n is equals to summation k varying from minus infinity to n delta of k I can write. Therefore, by using of summation property, we already gone through this. Based on the summation property, we know that delta of n, the dtft is going to be 1. Using summation property, I can write that u of n is going to be summation k varying from minus infinity to n delta of k. Dtft is going to be 1 divided by 1 minus e raised to minus j omega plus pi summation k varying from minus infinity to plus infinity delta of omega minus 2 pi k. For one cycle, I can write as u of n, the dtft is going to be 1 divided by 1 minus e raised to j omega plus pi into summation k varying from minus infinity to plus infinity delta of omega. Only for one cycle. If you want the whole cycle, I can go with the minus 2 pi k. If you are going for only one cycle, delta of omega is enough. Next problem is of show that the dtft of the sequence x of n is equals to e raised to j omega naught n is given by x of e raised to j omega, that is equals to summation k varying from minus into plus infinity 2 pi delta of omega minus omega naught plus 2 pi k. We know that the plus 2 pi 2 pi k. Using of frequency shift property, what I can write e raised to j omega naught n, the dtft is going to be summation k varying from minus infinity to plus infinity 2 pi delta omega minus omega naught plus 2 pi k. This is what the solution. Simple. Next problem is a find the dtft of the signal x of n is equals to minus 1 power n u of n x of e raised to j omega is equals to summation n varying from minus infinity to plus infinity x of n e raised to minus j omega n. Substituting for x of n, then minus 1 power n u of n, then solving for this. Based on our u of n function, the limit is going to change from 0 to infinity. Then here it is written as summation n varying from 0 to infinity minus e raised to minus j omega power n. Use the equation. Then I will be writing as 1 divided by 1 plus e raised to j omega. Here a small modification done, taken from the equation the e power minus j omega by 2 as a common. So the leftover part is going to be e raised to j omega by 2 plus e raised to minus j omega by 2. This is nothing but our 2 cos omega by 2, and this is taken in the numerator part, e raised to j omega by 2. Therefore, omega should not be equals to 2 pi k plus 1 by 2, where k is the value varying from 0 to infinity. It's dotted, right? For that reason, this is what the solution. Then the next problem is of evaluate the dtft of the signal and also find the expression for magnitude and also the phase spectra. Here the equation is given as x of n is equals to 1 divided by 2 power n u of n minus 4. We know that x of e raised to j omega is equals to summation n varying from minus infinity to plus infinity x of n into e raised to minus j omega n. Then summation n varying from, based on this you have to take u of n minus 4 is there, for that reason n varying from 4 to infinity 1 by 2 power n e raised to minus j omega n. Then summation n varying from 4 to infinity. I can write the equation as 1 by 2 e raised to minus j omega power n. Power n is taken common here for both the terms. Then use the equation. What I can write? X of e raised to j omega is going to be equals to 1 divided by 2 e raised to minus j omega power 4 divided by 1 minus 1 by 2 e raised to minus j omega. Then magnitude is going to be mod of e raised to j omega is equals to only of magnitude means only of this part 1 divided by 2 power 4, okay, divided by square root of 1 minus 1 by 2 cos omega whole square real term, and then the imaginary term is going to be 1 by 2 sin omega whole square. This e raised to minus j omega you have to take as cos omega minus j sin omega, that you have to take, and then you have to write the magnitude part. Then about the phase of x of e raised to j omega is going to be, what is the power is going to be minus 4 omega minus tan inverse of imaginary is of sin omega divided by 2 minus cos omega. This is what the equation you will be getting of. Then compute the Dtft of the signal x of n is equals to 2 power n u of minus n. What you have to use the equation and then substitute for x of n here, and u of is of minus n means n is varying from minus infinity to 0 to raised to n e raised to minus j omega n. Now putting m is equals to minus n, then the limit is going to be changing as m varying from infinity to 0 2 power minus m e raised to j omega m. Then changing the limit here where our m is varying from 0 to infinity, then the power is going to be changing here. In the 2 power minus 1 e raised to j omega power m, solve for this, we will be getting as 1 divided by 1 minus 2 raised to minus 1 e raised to j omega. Then x of e raised to j omega is going to be 2 divided by 2 minus e raised to j omega, you will be getting off. Then find the Dtft of the signal x of n is equals to 1 divided by 4 power n u of n plus 4. Same procedure. What you have to do? Use the equation, substitute for x of n, that is 1 by 4 power n, and here n is varying from minus 4 to infinity. Then put m is equals to n plus 4. Then the equation is going to be changing as m varying from 0 to infinity 1 divided by 4 power m minus 4. Instead of n, it's substituting as m minus 4 based on the equation of this. Then e raised to minus j omega into m minus 4, and then solve for this, and you will be getting as 256 e power j 4 omega divided by 1 minus 1 by 4 e power minus j omega.